means questions not up to the standard 12 question. So let's start with question number 2.
Okay.
Factorize. Which one you want me to do?
Could we do C?
Okay, let's do C part. So it is x squared
Yeah.
plus 10x
Plus
plus
20.
21.
Yeah.
So 21, see the coefficient of x squared. Coefficient of x squared is 1 and constant term is 21. So 1 times 21 is 21. And 21 has one pair of factor, that is 3 and 7. Okay.
Yeah, you would add up to 10.
That add up to 10. So we can just club these two factors, x square plus 3 times x plus 7 times x plus 21. So taking x common, we have x plus 3 and plus 7 common, x plus 3. So again, we have x plus 3 common and x plus 7. So this will be the answer. That's it. So it's quite easier. In fact, in all the questions we have to just use the middle term splitting in almost every question. Now doing question number 3, I part. Okay, question 3, part I.
Okay, so that's x squared plus 8x minus 48.
No. Question 3, I part. It is
Oh,
x
sorry.
squared negative 20x plus 36. So how is the weather there in South Africa?
Today it was good. It didn't rain today. So it's been just nice. Not hot, not too cold. Normal weather. Yeah.
Okay. So here we have 36 times 1 is 36. Now if we take the pair of factors, one pair of factors is always the number itself and 1. And if we take 2 and 18, we need not to go further. Why? Because 18 plus 2 is 20. So we can just write down x squared negative 18x negative 2x plus 36. So x is common, x minus 18 minus 2 and x minus 18. So this will be x minus 2 times x minus 18. This will be the answer.
Okay, if you put it like x minus 18 and then x minus 2, that would be correct as well.
Yes, it is. Yes, it is.
Okay.
That actually does not affect the result. That is the same thing.
Okay.
Let's use this space. Okay. So now question number 4, and let's do which part? N part.
Yeah.
Yeah. Do you want to ask any other part? You can.
Question 4.
No, I think one question from each part, means one part from each question.
Yeah, N is good. It's fine.
X squared negative 7x, x squared negative 7x, and negative 18. So 18 has factor 2 times 9, right? So we can rewrite this expression as x squared negative 9x and negative positive 2x. Okay. and
Yep.
negative 18. So we have x is common, so x minus 9 and plus 2 times x minus 9. So this will be x plus 2 and x minus 9. Okay.
Hmm. Yeah, I got it.
Now question number 5. Any part that you like me to do?
Question, could do K, 5K.
Okay, 5k.
Or
K part is x square plus 13x. So this is the most easier part. This is one of the most easy question. X square plus 13x, we have just two terms, right? And between these two terms, x is common only. So this will be x times x plus 13. That's it. This will be the answer. Okay.
yeah.
Okay. We did 5k na? Yes, 5k.
6N.
Yeah. Question number 6.
6N.
6n. Okay. 6n, we have x cube negative 3x square and negative 28x. We see that x is common in all the terms. So x can be taken outside. X square minus 3x minus 28. So this is x times, and again, we can factorize the quadratic expression in the brackets. Means we can factorize this expression, right? X
Yeah.
square minus 3x minus 28. So this can be 28 has 2 factors, 2 14, okay, 4 7, and these two can make negative 3x, isn't it?
Yeah.
So we have x square negative 7x positive 4x minus 28. So this will be x times x minus 7, and take 4 common. So this will be 4 times x minus 7. So we have x times here x times. Okay, yes. X times x minus 7 and x plus 4. This will be the answer.
Okay.
Question number 7. Yeah. Which part you want me to do?
Well, 7A then.
7a.
7A, yeah.
Okay. This is negative x square negative 3x and positive 54. And we know that 54 has a pair of factors 9 and 6. 9 times 6 is 54 and 9 minus 6 is 9 negative 6 is 3. So we can use that factor negative x square negative 6x positive 6x plus 54. Have you understood the last step? Yes, Rajvi. Did you understand?
Could you say it again, please?
See, 54 times 1. 54
Yeah.
has two factors, 6 and 9. Okay. And if we take negative 9x and positive 6x, they make negative 3x, isn't it?
Yeah.
So now we have negative x is common between these two factors. So taking negative x as common factor. Okay. Oh, what happened? Just a minute. I have to partition from here so that we can. Okay. Yes. So taking negative x common, we have negative x. If we take negative x common, then x plus 9 will be there. What do you say, Rajveer? And between these two terms, we have 6 as common factor, x plus 9.
Wait, so because we took out minus x, that the minus signs will go away then, right?
Yes.
Okay.
If we take negative sign common outside the bracket, outside the parenthesis, then sign will be altered. So we have x plus 9 times negative x plus 6, or we can write 6 minus x. So this will be the answer. I hope you understood it.
Yeah, I understood.
I'm making you understand one more question, that is K part 7K. 7K is 20x minus 2x squared negative 50. Okay, so this can be written as negative 2x squared, positive 20x, and negative 50. We have just arranged the terms in proper sequence. What is the proper sequence? We first take the highest degree variable, highest degree term, and then we write in descending order. Okay.
Yeah.
So first x square term, then x to the power 1, and then constant term. Now we have 50 times 2 is 100. And if we take 10 and 10, these two factors, we see that they add up to 20. They add up to 20. So this will be negative 2x square plus 10 times x plus 10 times x negative 50. Is it?
Yeah.
So taking negative 2 common, negative 2x in fact, negative 2x common. So from first term we have x, and since we have taken negative sign before the parenthesis, before the bracket, we have negative sign over here. Okay, x minus 5. And between these two terms, 10x minus 50, we have plus 10 common, x minus 5. So we can see that x minus 5 is common over here. Okay. So x minus 5 can be taken as common, and negative 2x plus 10. And one more thing, we can take 2 common from these two terms as well. You can either take 2 common factor outside the parenthesis, or you just can write this way on. So x minus 5, and here we have 2 times 5 minus x. 2 times 5 minus x is what? 10 minus 2x.
Yeah.
So this will be the answer. And if you take negative 2, then you can write this as x minus 5 whole square as well. Getting me? If you take negative 2, then it will be x minus 5 times x minus 5.
Hmm.
The simplest approach. Okay. I hope you understood all these questions. So hopefully you will be able to do some of them.
Yeah.
Not expecting all the questions that you will be doing, because uh, in one question there are several parts and they all of them are of same type, right? So no need to do all the questions, but yes, uh, take alternatively or even parts or odd parts, whatever you like. Okay.
Yeah.
Uh, did you ask about the syllabus in your school?
Oh yes. And I got the books that we are using for this year.
You got?
I got the books.
Okay, you got the books.
Okay.
So
These are the A level books as well. This is AS and A level maths. Both
yes,
the books.
yes, yes.
I'll send you a picture now.
Yeah, send it. Yeah, it's pure mathematics, ASL level. Yes, AS and A level mathematics. That works. Okay. Can you just send me the a few pages of your first chapter, if you could?
The like the index or like the pages of the first pictures of the.
Send index first and uh, pages from the chapter also. First, send me the index page so that I can just go through. However, I am aware of the syllabus and all. Yeah, these are the same things. In fact, polynomials, modulus function. Polynomial, we are studying polynomial only. Okay, we
Hmm.
studied about zeros of polynomial, roots of polynomial, nature of roots. These all are from polynomials. And second chapter is the modulus function. We'll be studying modulus function. Okay, exponential and logarithmic function. We will do that. Differentiating. Almost all the topics are the same, in fact. But yes, this is the AS level book. So it's good that you have got the book now. So it was necessary.
Yeah.
Doing the things uh, from the same standard would work well.
I'm also
Okay.
sending the syllabus now.
So uh, can you send me some pages of polynomials? Send me. However, I have books for. I think this book will be is available with me. I'll just have to check it from Google Drive. But that would be little bit, it is 2 3 years uh, back. Syllabus might differ because after pandemic in all over the world, syllabus has been revised for
Hmm.
ASL level or ASL level. Okay. Yeah. So polynomials we are already doing. Now today I am going to write some identities which will be used in polynomial chapter, right?
Yeah.
Identities. First one is a plus b square. You must be knowing that. What is that?
Sorry.
What is the identity for a plus b square?
A squared plus AB.
2ab, 2 times ab.
2AB plus B squared.
Yes. And a minus b square is a square minus 2ab plus b square. A square minus b square is what? A plus b times a minus b. And x plus a times x plus b is x square plus a plus bx plus ab. AB are just for the reference. In place of A and B, it might be means X, Y, or 2X, P, Q, anything, any variable can be taken in that. Okay? Any
Okay.
variable, constant, anything can be taken. Suppose we have 102 square. That can be written as 100 plus 2 square. And that can be derived in the form of A square plus 2 AB plus B square as well. Okay? We have a plus b plus c whole square is a square plus b square plus c square plus 2 times ab plus 2 times bc plus 2 times ca. And a cube plus b cube plus c cube negative 3abc equals to a plus b plus c times a square plus b square plus c square minus AB, minus BC, and minus CA. We have A plus B whole cube, A cube plus B cube plus 3 times AB times A plus B. You can also rewrite this A cube plus B cube plus 3 times A square B plus 3 times AB square. And what about A minus B whole cube? A minus B whole cube, A cube minus B cube minus 3AB, A minus B. Or you can write A cube minus B cube minus 3A square B plus 3AB square. Okay? These are the basic identities that will be used in polynomials. Polynomials, poly means many.
Menu. Yeah.
Nomial means terms. Okay, many terms. So if we have just one term, suppose x to the power 100, so this can be said to be as monomial. If we have two terms, suppose x to the power m minus a to the power n. So this is what? Binomial, because we have two terms. And if we have x square minus 3x plus 2, how many terms are there?
3.
Yeah, 3 terms are there. So this can be said to be as trinomial.
And then 4 is quadratic.
And suppose we have x cube minus 3x squared plus 2x plus 5. So polynomial.
Oh, okay.
In general, every even monomial is said to be the polynomial. Even constant 3 is what? Constant polynomial. Even constant is called, even a constant can be called as constant polynomial. So how will you define a polynomial? How will you define a polynomial? What is polynomial? Can you explain?
Um, it's like it's a it's isn't it? It's an equation or an expression with many terms, multiple terms.
Yes, up to some extent you are correct. See, polynomial is defined as a to the power a0 x to the power n, okay, plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 and so on to an for n terms, okay, where a0, a1, a2, an are constant or real numbers, are real numbers. And the powers, indices, and all the powers are whole number. That is most important thing. All the powers are whole numbers. Okay. So I am just giving some examples. Suppose we have x cube plus 2x square plus 3 root x plus 5. Is it a polynomial or not?
Yes.
What is is it a polynomial? Yes? No.
Yes.
It's not a polynomial. Why no? Because
Because of
what is the
the
power of x? The power of x over here is half. And what I told you earlier that power should not be other than whole numbers. Power should not be fraction or negative. It should be whole numbers from 0 to anything. But that should be whole number only. Only then we can call them polynomials. Okay. Now I am giving one more example. We have x plus 1 over x plus 3. Example 2. 3 is x to the power 100 plus 3x square minus 5. Fourth, root x plus 1 over root x equals to 0. Fifth, root x plus 2 root x equals to 3. Yes, tell me. Not equal to 3. No need to use equation in case of, we are just using expression. So no need to use equation for that. So tell me about the second example. Is it a polynomial or not?
okay. It is.
It's again again it's not a polynomial. Why? Why it's not a polynomial?
Oh, because of the 1
See,
over x.
see this one. Why the
Yeah.
power of x? Power of x is negative 1.
Yeah.
Negative 1 is an integer. It's not a whole number.
Yeah.
What
Okay.
about third example? Is it a polynomial or not? Is it a polynomial or not?
Yes, it is.
Yes, it is. Yes. Because x to the power 100, 100 is
A
whole
whole number.
number, x is square, 2 is whole number. So
Yeah.
if the powers are whole numbers, then they form a polynomial. And what about fourth example?
This is not.
This is not a polynomial. Yes, no. And that goes for fifth example as well. Okay. Now it should be very clear into your mind that what are polynomials and what are not. Is it?
Sorry?
Now I think, according to me, means your concept about polynomial must have been cleared so far. With, what are the polynomials and what are not? Isn't it? Can you explain once again what are the polynomials?
Like the definition of polynomials or a polynomial?
You can just you can just say if the powers of variables are whole numbers, then we can call them polynomials. Otherwise, they are not polynomials. As simple as that.
As long as the powers of the variables are whole numbers, it is a polynomial.
Yes.
Okay.
Now, degree of a polynomial. So these are the basics. Not necessary that these all things will be in your book because you are in 12th grade and some of the things started in junior classes. Okay. But I'm just taking, before jumping to the chapter, I'm taking the basic things as well. Okay. But many of things, most of the things will be in your chapter. Degree
Okay.
of polynomial. What is the degree of polynomial? The highest power of the variable. Degree of polynomial is what? The highest power of the variable in a polynomial is called the degree of polynomial. Degree of the polynomial. So if I ask you what is degree of a polynomial, how will you identify that? How will you identify the degree of polynomial?
Well, we'll just see which power is the highest in that expression, right?
Okay, let us take some examples. Two times x square negative 5 times x positive 3 times x to the power 4 plus 5x cube minus 12. What is the degree of polynomial? What is the degree of this polynomial?
It would be 4.
Yes, it is. This is the highest power of the variable.
Yeah.
So this will be the degree of the polynomial. So degree of polynomial is 4. X to the power 100 minus a to the power m. What is the degree?
100.
100, yes. 100 x to the power m minus a to the power m, where m n belongs to whole number. What is the degree of polynomial? This is also m. Yes.
It says where
M belongs to whole number.
Okay. So it would be mn.
This degree is m. Okay, m only, not this one. Okay, degree is the highest power of variable, not the constant. Degree is m. What is the degree of a constant polynomial? Constant polynomial. Suppose we have 3 is a constant. So what is the degree of 3? This is little bit tricky. What is the degree of constant polynomial? There is no variable at all, isn't it?
Hmm?
So see, 3 can be written as 3x ki power 0. 3x to the power 0.
Yeah.
Anything to the power 0 is what? What is
1.
the value? Anything to the power 0?
Is 1.
It's 1. So 3 times 1 is 3. So 3 can be written as 3 into x to the power 0. So what is the degree of this polynomial?
1.
No, it's 0.
Oh.
Degree
Okay.
of a constant polynomial is 0.
Okay.
And one most important and tricky question I am going to ask you. What is the degree of a 0 polynomial? 0 is also a constant. 0. Tell me. What is the degree of a 0 polynomial?
1.
It's not 1 actually.
So then what can it be? 0?
Not 0. Why
Yeah,
not 0?
because
0
alternative.
can be written as 0 into x to the power 0. But 0 can also be written as 0 into x to the power 100. 0 into x to the power anything, 1000. So degree is not defined actually. Degree of a 0 polynomial is not defined. Degree,
Anything times 0 is 0.
yes. Degree not defined. Okay. Now, zeros of a polynomial. What are the zeros of polynomial? We already studied, in fact. So zeros of a polynomial. We studied only quadratic polynomial. Now we are studying in general all the polynomials. Zeros of a polynomial. So what is the zeros of zero of a polynomial? What is the zero of a polynomial?
The zeros, sorry?
What is a zero of a polynomial?
It will be 0, no?
No, not at all.
Would it be undefined?
I ask you another question. What is the root of a polynomial? What is the root? What is the root of an equation? In previous class, we already studied. There is a thin line between 0 and root. They are actually the same thing. The word zeros of a polynomial is used for expression, polynomial only, and roots are used for the equation. So what is the zero of a polynomial? No idea?
What is the 0?
The value of x, the value of variable, the value of variable in the polynomial which makes it equal to 0, equals to 0. What does it mean? Suppose we have expression polynomial 2x plus 3. Okay. So value of x which makes 2x plus 3 0 will be called the zero of polynomial 2x plus 3. So how do we find 0? So first we make it 0 and then we solve the equation. So x equals to negative 3 over 2. If you put x equals to negative 3 over 2, you will see that it becomes what? 0. So negative 3 over 2. Therefore, negative 3 over 2 is a 0 of px equals to 2x plus 3. Do you understand?
Yeah, I understand.
So the variable of, value of the variable which makes the whole polynomial 0. That is called the zero of polynomial. Okay. And the same thing we have done while we were solving quadratic equations and we were finding the roots of the equation. Roots are nothing. The roots are the value of variable which satisfies the given equation, right? Suppose we have 2x plus 5 equals to 3x minus 2. Okay. So value of x which satisfies this equation. So how do we solve it? We bring all x terms together. So we have 5 plus 2 equals to 3x minus 2x. So we have 7 equals to x. So x equals to 7 should be satisfying this equation 1. If we put x equals to 7, put x equals to 7 in equation 1. Then we have 2 into 7 plus 5 and 3 into 7 minus 2. 2 into 7 is what? 14 plus 5 and 21 minus 2. So 19 equals to, so it satisfies the given equation. Have you understood?
Yeah, could we do another example?
Yes, sure. There is no such difference between zeros and roots. The only thing is roots are used for equations and zeros are used for expressions. What is the difference between an expression and equation? Equation has equality sign, and we have terms in both sides of the equal sign, right?
Yeah.
That is called equation. And polynomial or expression is what? Which have just a certain number of terms with associated with plus or minus. Okay. Let us take another example. Suppose we have polynomial px equals to x square minus 2x and plus 6 minus 6. Let's take minus 6. Okay. So we can rewrite this x square minus 3x plus 2x minus 6. And this can be written as x into x minus 3 plus 2 into x minus 3. So x plus 2 and x minus 3. So if we make it 0, we have x equals to negative 2 and 3. These two things are nothing but zeros of polynomial, zeros of px. Did you understand?
Yeah.
So the value of x actually makes the whole polynomial equal to 0. That is why it is called zero of the polynomial. That's it. This is called zero of the polynomial.
Okay.
So one more thing. Very important. This is called factor theorem. I'll make you understand factor theorem. This might be in your syllabus. I'll check it. And before the next class, please send me the PDF of the whole chapter. However, I'll look for the book, the same book. I might have, because I have been teaching for a long time to IGCSE board. I might have, but sometimes, they are either very old or in the time of, pandemic, I saved somewhere and I forget that is quite possible. Because in most of the cases, whatever the student means, whoever the students I have, they generally send the PDF and I teach from there only. Okay. So before the next class, please send PDF of the whole chapter. Factor theorem says if A is a real number, such that f of A, f of A or P of A, whatever. You can take polynomial with A or function with A. PA equals to 0, then x minus A is the factor of Px. It is quite easy to understand. See, in the above example, we have -2 and -3. Okay. In the above example, we have -2 and -3. This is -2 and this is 3. Okay. So if -2 and and +3 are the zeros of Px, then x negative times. Okay, let me take this pen. X negative of A. A is what? -2. Means x plus 2. And another is x minus 3. These two are the factors of the polynomial. And we see that we have already factorized it, and we see that x plus 2 and x minus 3 are the factors of polynomial with variable x, Px. So if a number, real number, which makes polynomial 0, okay, then x minus that value, that real number, is the factor of given polynomial. Did you understand? Suppose we have x equals to 3, which makes x square minus 2x minus 3. Okay. If we put x equals to 3, if we put x equals to 3, then we have 3 square, -2 times 3, -3. That means 9 minus 6 minus 3. So this becomes 0. If the value of x, which is 3, makes the polynomial 0, then we can say x minus 3 is the factor of the given polynomial. Did you understand?
Yeah, I understood.
And this comes under factor theorem. Okay. So it's time to give homework to you. Homework is what? The same polynomial, and go through the polynomial chapter so that we can study in the next class. And also ask your faculties or whoever concerned authority is that which are the topics that will be coming into the next exams. Okay, in ASL or AS, whatever. Okay.
Okay.
So you have to go through polynomials and factorization.
From the book, right?
Yes.
The new one.
From new one, go through polynomial and factorization. I already sent you.
Okay.
So you can do from there. And factorization is also the part of polynomial only. Very not the different.
And the previous like factorization, those questions.
Yes, yes.
Yeah. Okay.
So take care. Have a great evening. What's the time there?
Currently it's 8 o'clock. So I'll have dinner now. Yeah.
Yeah. Please have this.
Okay.
Take care. Bye.
Thank you so much, sir. Bye.
And also, please give feedback to Urban Pro. Okay, write something.
Yeah.
Okay,
Right.
bye.